Okay, guys, so previously we took a look at calculating interest using simple and using compound interest methods, right? And we saw that when we use simple interest that our money grows linearly, and when we use compound interest, our money grows exponentially. So seeing as, and you correct me if I'm wrong, if this doesn't apply to you, no problem. Seeing as, if our money's going to sit there and do nothing but sit there, we want it to grow as quickly as possible, if it's sitting there anyhow, right? So that means that, are we going to want it to grow exponentially or linearly? Exponentially, for sure. And then we went on to talk about the two formulas for calculating interest, calculating your amount invested with simple interest and with compound interest. And so now we're going to take a look at this here today. So I've just rewritten this, which stands for the amount that you end up with. Okay, so I'm just going to say it in English. The amount that you end up with is the original amount, called the principal, times 1 plus whatever the interest rate is, to the power of, because we're doing an exponential function, to the power of the number of times it's been compounding. So I'm going to ask you a few questions verbally, like orally. We're not going to write them down. I want to make sure that you're good with this. Oh, look who's here. Jacob, come on in. You've got a test to write that you missed. Oh, I'm so sorry. How are you doing today? Good. Oopsies. Just 1 second here. Jacob. Okay, folks. You're welcome. Okay, show me what you know, all right? So here, back to the verbally, sorry. So when we talk about amounts compounding, what we mean is how many times does a certain period of time occur in a year? So when I say that, this is what I mean. I think an example is going to be really helpful. You know, sometimes it doesn't really come out clearly until you hear some examples. So if something is compounded annually, then the number of times it's compounded a year is once. If something is compounded semi-annually, or every 6 months, then the number of times it's compounded in a year is twice. Well, there's that under the phone. Let's give it a go. If something is compounded quarterly, that's every how many months, Visa? Quarterly. Right, every 3 months. So that's 4 times in a year. So if something is compounded quarterly, then there will be 4 compounding periods in a year. Do you see what I mean? So this N here is the number of times. Just rip the Band-Aid off real fast. Go. Zoom. You got it. There you go. So that's what this N is, the number of times it's been compounded in a year. Alrighty? So I'm just going to write that here. Oops, yep. And in finances, or financial math, we like to use the word for a year, we like to use annual, or it occurs annually. Have you guys heard that word before? Okay. Are you guys awake? This one's not awake yet. No, I can see in her face. Carla, you're awake, aren't you? I think so. I love it. She's not sure. She's going to have a conversation with herself and let us know. Okay. So now let's talk about this, because we know this is obvious. This is the amount we end up with. This is the amount we start with. And this we just had to deal with. We know that one is, remember before when we didn't have the one there, we just got the interest, but we have to add the interest to the 100% of the amount that we had in the first place, right? We did an example like if you have $100 in the bank at 5%, okay, let me give you a real life situation, at the most 1%, then at the end of the year you don't end up with $1. That's your interest. You end up with $101 because you still have 100% or 1.00 of what you started with. Now this rate, now the rate will depend on how many compounding periods there are. So for example, let's say you have a rate of 6% a year, but it's compounded semi-annually. What that means is they're going to cut it in half because there's 2 periods semi-annually. There's 2 compounding periods in the year. So instead of getting 6%, what they do is they give you 3% on the first 6 months and bless you, and 3% on the last 6 months. If you have 12% compounded quarterly, that means every 3 months you're going to get a quarter of 12 or 3. Okay? So basically what we're doing is whatever the rate is, we're dividing it by the number of times we have compounding periods in our year. Right? Remember, if it's compounded semi-annually and it's 8%, that means we're going to cut that in half. We're going to do, or divide by 2. We're going to have 4% the first 6 months and 4% the last 6 months. So this rate really is your interest divided by your compounding periods. Compounding periods. So this is really r over 1. We've seen fractions. We know you just want something to be a fraction, you put it over 1. When the whole thing, when there's only one compounding period in the year, so it's really r over 1. Now it's going to be r over 2 if it's every 6 months, or r over 4 if it's every 3 months. Let's do some examples. Forget about this. I know you know how to use your calculator. Okay. Calculate I, so that they call it I now in the book. They were using R, so I used R. This is I. This could be I or R. Okay? So calculate I as it would appear in the formula for the given situations. So what will this be? In other words, what will the fraction be? So 5% quarterly will be 0.05 divided by what? 4, because there's 4 quarters in a year. 0.3% is 0.003 divided by 2. 2 times in a year is semi-annually. 1.25% is 0.0125, right? We move the decimal over 2 spots. And monthly, how many of those are there in a year? 12. Let's do this one. 4.2%. I'm going to write it over here. 0.042 over how many weeks are in a year? So what's biweekly if every 2 weeks? 26. Half of 50. You probably said 26. I just didn't hear you. That's all. Half of 52, right? Oh, look who's here. Hi, what's up? I'm fantastic. How are you, friend? Good. Come on up. Grab the test that you missed last week. Have a seat and show me what you know, okay? So now we're going to do E. So 0.0. You don't really need it. Well, okay, whatever, take it. Yeah, you do. You do, you do, you do. You do, you do, you do, you do, you do. Okay, let's take a look at this. Did I do this decimal right? So from here is 1, 2. Yeah, I'm good. And what's this divided by? 365. And here, this is 12% divided by what? 1. Which is why initially we didn't even bother to mention that we were dividing by the compounding periods, because when we do it annually, it's always divided by 1, which doesn't end up being a fraction. Right, Carla? Okay. So now these are the little bits that you would put in for R or I in this formula. So, what we're going to do is we're now going to go right down to here and do 5. So we've got this much is our principal, right? Remember, amount equals principal times 1 plus, I'll put I because the book is now using I, to the n. And we want to know if the interest is compounded quarterly, how much is earned by this. So let me do the first one with you. So for A, we have, what is 2? A, P, I, or N? N. And what's this amount? That's right, our original invested. And here's our percentage, right? So let's write this out. I'm going to first start with A equals P 1 plus I to the N. The amount is what we're looking for. The principal is this. Please watch before you write so you can really see what I'm doing. And then we've got 1 plus, and then our percent is 0.085, and it's divided by how many times a year is it compounded? How many times in 1 year? 4. And then we're going to put a 2 here. So that 2 deals with that, what you were going to make an 8. Okay? And then, yes, you need a calculator. Now, this is how I would put it in my calculator. So I'm just going to tell you to walk you through it. You know your calculator best, but this is what I would do to put it in my calculator. I would do 0.085 divided by 4 equals, get a number, add 1 to it, get a number, square it, press equals, get a number, and then multiply by this and get my answer. So start on the very inside and then build on out, out, out with the bed mass. Hi. So I got 476 and 11 cents. Is that what you guys got? And I rounded, so I'm putting a dot over my equal sign. 476.11. And of course I'm using units, which is dollars. So as always, I'm not asking you, oh my gosh, I couldn't figure that out on my own without you, Miss Weinrib. No way. That's not what I'm asking. What I'm asking is, are you following what I'm saying? Please, are you good? Okay, so do B and C and let's take them up. Oh shoot, I made a mistake, guys. This isn't a 2. This is 8. Because it's compounded 8 times in 2 years. So we need to fix that. Sorry about that. Did you get what I got? Good. Okay. Yeah. Okay, so what this question says is a non-zero base raised to the exponent something is equal to 1. So what if the base is not 0? So something to the power of what is equal to 1? Got it? Okay, so seeing as I messed up A initially, let's just make sure you guys are on track with B here. So we've got our initial amount is 2550. Our bracket is 1 plus our interest percentage in a decimal divided by the number of compounding periods in a year, quarterly, to the power of 4.5 times 4. Because there's 4 compounding periods in the 4.5 years. So that's 4, 8, 12, 16, and then how many quarters are there in 6 months or half a year? 2. So 4, 8, 12, 16, 17, 18, right? So I'm just going to rewrite this so you can see that. Anyone have a number yet? Let me know if someone else gets that. Carla, did you get that? Okay, so what was it again? 2,707? Even? Okay, so it's rounded. There's the dot. So what did you get for the exponent of this last one, C? How many quarters are there in 6 months? 2. 2 quarters in 6 months. What'd you get, Fiza? I just realized I forgot to put my units in B, so make sure you're not forgetting either. So let me ask you something. Does it make sense in C that the amount is hardly, only a tiny little bit bigger than the original amount, the principal? Yeah, it does. Why is that? Because it's such a small percent, and it's only been growing for 6 months, right? That's it.